we found the SQL injection vulnerability and see the entire table's name and surname values in one go. So, if we can do this, what else can we do? SQL map is a little bit complicated, but a very powerful command line application to exploit SQL injection vulnerabilities. You can download and use this free application in any platform, and it's embedded into Kali Linux. SQL map has a lot of parameters, so you can use -h parameter to learn more. For now, let's build the SQL map command. The first parameter is the URL. Since the program analyzes all the parameters, we don't need to give the vulnerable URL. But we know that the ID parameter is vulnerable. We can give it as the second parameter. Since we need to have a valid credential to reach the page in DAM vulnerable web application, we have to give SQL map a valid cookie. Not necessarily, but it is better to teach SQL map when it gets a valid result. In this example, we can give a static part of the valid page, first name, and last, we have to say what we want from SQL map. It says the banner is 5.1.41 3 Ubuntu 12.6_log. Let's ask for the current database at this time, --current-db. The current database is DVWA. Let's list the tables of the database. So here we go in deep. Let's dump the user's database. It says the database management system is MySQL. We already know it, so we can skip to other database management systems. In questions, the default answer is shown in all caps. If you hit enter, the default answer is selected. It says the ID parameter is vulnerable, so we can skip other parameters at this point. It found hash values inside the table and asks if we want to save it for further use. Moreover, it offers to crack the hash values. So let's use SQL Map's default dictionary in this example. And finally, we have the dump of the user's table and hash values are cracked. Good job. Blind SQL injection is used when a web application is vulnerable to an SQL injection, but the results of the injection are not visible to the attacker. The page with the vulnerability may not be one that displays data, but will display differently, depending on the results of a logical statement injected into the legitimate SQL statement called for that page. This type of attack has traditionally been considered time-intensive because a new statement is needed to be crafted for each bit recovered, and depending on its structure, the attack may consist of many unsuccessful requests. Now, thankfully, there are several tools that can automate these attacks once the location of the vulnerability and the target information has been established. Now, we already know one of them. It's SQL map. An SQL injection is a well-known attack and easily prevented by simple measures. With most development platforms, parameterized queries, also known as prepared statements, that work with parameters can be used instead of embedding user input in the statement. A placeholder can only store a value of the given type and not an arbitrary SQL fragment. Hence, the SQL injection would simply be treated as a strange and probably invalid parameter value. If the application is developed with an object-oriented programming language, using object relational mapping libraries avoids the need to write SQL code. The ORM library, in effect, will generate parameterized SQL statements from object-oriented code. A straightforward, though error-prone way to prevent injections is to escape characters that have a special meaning in SQL.